In the vast expanse of our solar system, there are countless wonders, from the swirling gas giants to the icy moons of distant planets. However, one feature stands out for its sheer size and majesty: Olympus Mons, the tallest known mountain in the solar system. Situated on the surface of Mars, Olympus Mons is not just a peak but a colossal structure, dwarfing any mountain on Earth and outshining the tallest peaks of all the planets in our solar system. To understand the enormity of this mountain, it is essential to explore its characteristics, origins, and the unique processes that gave rise to such a giant. Olympus Mons rises to an astounding height of approximately 22 kilometers, 13.6 miles, making it nearly 3 times the height of Mount Everest, Earth's tallest mountain. Its sheer size alone is mind-boggling, but what truly sets Olympus Mons apart is its base. The mountain spans an area roughly the size of the state of New Mexico, with a diameter of about 600 kilometers, 373 miles. Such a vast footprint makes Olympus Mons not just tall but incredibly wide, with its slopes gently curving outward, giving it a shield-like appearance. This vastness and towering height give it a unique position in the solar system as the largest volcano, and, by extension, the tallest mountain, ever discovered. The scale of Olympus Mons is so immense that it defies easy comparison to anything on Earth. Earth's largest volcano, Mauna Loa in Hawaii, is often cited as the largest volcano on our planet, but even it pales in comparison to Olympus Mons. While Mauna Loa rises to about 4,169 meters, 13,681 feet, Olympus Mons towers over it by a factor of more than 5. In fact, the size of Olympus Mons challenges our understanding of planetary geology, raising questions about how such a mountain could form on a planet like Mars, which has different geological processes and conditions than Earth. To understand how Olympus Mons reached its monumental size, we must consider its origins as a shield volcano. Shield volcanoes are characterized by their broad, gently sloping sides, which are the result of the eruption of low-viscosity lava that can flow easily over large distances. On Earth, shield volcanoes like Mauna Loa and Kilauea in Hawaii are famous for their lava flows that slowly build up the mountain over time. On Mars, however, the geological conditions allowed Olympus Mons to grow even larger. The planet's lower gravity, about 38% that of Earth's, allowed volcanic material to accumulate more easily, and the absence of tectonic plate movement meant that the volcanic activity could continue uninterrupted for millions of years. As a result, Olympus Mons became the towering structure it is today. Another key factor in the formation of Olympus Mons is the lack of erosion and weathering on Mars. On Earth, wind, water, and other weathering forces continually shape and erode mountains, limiting their height and size over time. Mars, however, has a thin atmosphere and no liquid water on its surface, which means that the forces that would normally wear down a mountain are virtually absent. Without these erosive processes, Olympus Mons has remained a massive, nearly pristine structure, retaining its enormous size for billions of years. One of the most striking features of Olympus Mons is the caldera at its summit, a vast depression that measures approximately 80 kilometers, 50 miles, in diameter. This caldera, which is the result of multiple volcanic eruptions over time, is one of the largest known volcanic craters in the solar system. It serves as a reminder of the immense volcanic activity that once took place on Mars. As lava erupted from beneath the surface, creating layers upon layers of rock that eventually formed the mountain. These eruptions, likely occurring over millions of years, created the massive shield volcano that we see today. The caldera itself is thought to have formed as a result of the collapse of the volcano's surface after volcanic activity ceased, further adding to the complexity of the structure. Interestingly, the formation of Olympus Mons provides insight into the past geological activity of Mars and its potential for supporting life. The massive volcanic eruptions that created Olympus Mons could have played a role in the early climate and atmospheric conditions of Mars. During the planet's history, volcanic activity likely released gases like carbon dioxide and water vapor into the atmosphere, which may have contributed to a warmer climate and a thicker atmosphere, conditions that could have supported liquid water on the surface. The presence of ancient lava flows and other volcanic features suggests that Mars was once a more geologically active and potentially habitable world, with conditions that may have been suitable for life. Despite the mountain's colossal size, Olympus Mons remains an area of ongoing scientific interest. Researchers continue to study its composition and structure using data from NASA's Mars orbiters and rovers. The study of Olympus Mons not only helps scientists better understand the geological history of Mars but also provides valuable insights into volcanic activity on other planets. The size and age of Olympus Mons make it a prime example of how large-scale volcanic features can form under different conditions than those on Earth. By studying Olympus Mons, scientists can also learn more about the tectonic history of Mars and the processes that led to the formation of the planet's surface features. The fact that Olympus Mons exists at all is a testament to the unique conditions of Mars and the ways in which planetary bodies can evolve over time. Its size, formation, and persistence offer a glimpse into the history of volcanic activity on Mars, as well as the planet's potential for supporting life in the distant past. As space exploration continues to advance, Olympus Mons remains a focal point for scientific inquiry, its towering peak standing as a reminder of the incredible power and scale of natural processes in our solar system. It is not just the tallest mountain in the solar system, it is also a symbol of the mysteries and wonders that await discovery on Mars.